Good morning and welcome to the first video on real analysis. This is Math with Mahadev channel and this is my first video. So we are going to start real analysis and later we would be covering differential equations and also some topology. All mathematical topics would be covered. So please like, share and subscribe. So, starting with real analysis. Real analysis is one of the fundamentals in mathematics, and this is a very interesting topic. And many of them find it bit tough because they are not able to imagine the statements that are being said in real analysis. And this real analysis works as the foundation for differential equations and all theorems in mathematics. So real analysis, though it would be a bit slow, but we would be trying maximum to make this engaging, motivating in the further videos also. Okay, so to start with real analysis, the first what we want to know about real analysis is the mathematical statements. It's mathematical statements. So, what are mathematical statements? So, mathematical statements are basically like, two simple statements must be formed to make a compound statements. Got it? No. So, I'll just say two simple statements. Two, sorry, two simple statements, okay, is combined together to make a compound statement. So this is just a basic, very simple kind of thing. This is nothing big to think about it. This is just basic language thing. So this is, I just said it. Okay. So just getting into the topic. So what are mathematical statements? So what is the definition of a mathematical statement? A mathematical statement is a sentence. Okay. That is either true for all the cases which is mentioned in the sentence, or it is false for all the cases covered by it. So a mathematical statement. Okay. So what does a mathematical statement mean? A mathematical statement. A mathematical statement is a sentence. Okay. So first you must understand is that it is a sentence, and second thing that either it must be true or and whatever you can use. This we will cover up later. Okay, this we will cover later. Either it must be true or it must be false. Got it? So this is the basic understanding of a mathematical statement. So after covering that mathematical statement, I'm just explaining it because all these things you already know, because since you are basically into a mathematical background. So this video does not require anyone to be into mathematical background. Even if you are known from a non-maths background also, you would be able to understand this. But deeply apologize, this is my first video, so there would be some hitches here and there, which would be rectified in the later videos. But I will assure that the content would be very good. Okay. So we can say any statement. Okay. So just say some statements. All sorry, it's all color. Like some statements like all flowers have blue petals. So is this a statement true or false? Just pause and think on it. Is this a statement true or false? This is a sentence. It must be either true or either false. Okay. So this is a false. So this is a mathematical, this is a statement in fact. This is a statement. Okay. So there is no argument like this is whether it is a statement or this is not a statement. So this is a statement. Then next, if I say that the set of stars in sky is finite. Is it true or false? So it is of course false. So these are the things which we know as a statement. What a statement must constitute all those things. That either it should be true, or and false. So it must have two components. Either it should be true or false. True or false. True should be there or false must be there. Then only it would be a mathematical statement. Okay. So moving forward, hope these things are clear. These things are only just basic things which I am saying. There's nothing big or small to do. Then we can see some statements are not mathematical statements. Okay. Right. If I am saying that hmm, add 2 to 6, is this a statement? Hmm? No, this is not a statement. This is not at all a statement. It is just some command that is giving. It is just like an imperative sentence. Okay, it is an imperative sentence. So it is doesn't have anything to do with true or and false. It has nothing to do with these things. Okay, so this is not a statement. Is that clear? Okay. Now let's just move on to next the portion of the mathematics. So now what we are going to discuss is about the logical, logical connectivities. So now everyone would be thinking why in real analysis all these things are needed. But please understand that real analysis is all about proving. It's all about proofs. So the sentence that what we are going to write, it must be very clear. There must not be any confusion with regarding to whether this is needed or not. Like, you must not give a wrong communication to the other mathematicians. So this must be always kept in mind. Okay, so in logical connectivities, we would be discussing primarily on some things. One is a disjunction. Disjunction. Okay, we will come in detail. And the another is conjunction. Conjunction. And the third one, this is the most important thing. All are important, but this always you would be, it's like negation. Okay. So these are the basic three things which we would be explaining. So we would be going in detail with all these things. Okay. So first I am going to write is with respect to one is disjunction. When the name disjunction comes, okay, what you must remember first is the word or. Clear? Please keep it in your mind. Please underline this that disjunction means it's or. Or very simply I am saying it's or means just if you just if I just read out the definition, like even like p and q, if it is there, if it is like p or q, sorry, it's or the p or q, like what we say, any book, like the Da Vinci Code is a book. If I'm saying the Da Vinci Code is a book, or several men are aged above 40, I'll just write it. Okay, Da Vinci Code is a book. Several or several, this or remember this, several men are aged above 40. So what is this? Here we can split it as two statements. P, no, if two statements we are splitting it. The first statement is Da Vinci Code is a book. Okay, and the second statement would be several men are aged above 40. Is that clear? So in the statements you can see that either P is true or means what? Or means either, that only one is required. Okay. So in disjunction we'll write only one statement need to be true. That's it. Only one statement need to be true. So here two statements. Da Vinci Code is a book. That is a truth, right? Several men are aged above 40. So both these statements are true. So how will you denote this? Okay. So for disjunction, you will be denoting it as P you will write a V. Okay, V. This is the denotation for disjunction. Clear? So here, what is that? Either P is true or Q is true. Okay, we will just see another example. Hmm? Another example for this would be, say, suppose for P, okay, so I'm just writing here P is a statement hmm, where d by dt. I'm just taking a derivative. Hope everyone is clear with this. If not, I will just upload, just put it in the comment box. I will be doing videos with regard to differential calculus, but not immediately. First, I would be completing real analysis. Then only we would be moving to the differential part. So here I am writing t cube plus 7t. Okay, so equal to hmm, 3t square plus 7. So I'm just splitting this into two elements. Okay, one, one. This is P, and the second one is Q. Q I am writing something like maybe 2 plus 4 is equal to 7. Hmm? So what we are just looking is that whether this statement, now it negation, no, not negation, now whether we are seeing that this is disjoint. Okay, disjoint, disjoint P. We are just looking for this. Okay, so P d by dt. So d by dt of t cube plus 7t is, you know, it's 3t 3 minus 2 plus 7, right? This would be ignored. So it's again 3t square plus 7, right? So this is true. The second one is q is equal to 2 plus 4 is 7. No, this is false. But still it stands good. Why? Because it's or, right? Either of p or q must be true, right? So here what is this? P is true and Q is not true. So P is valid. This disjoint is valid, right? So this joint is valid. Hope this is clear. Now we will be moving to our next example. So if you need one example, then I can provide. Else, this is not a this is all basic things. So I don't want to take much time on discussing all these basic things. Okay. So the next thing is conjunction. Junction. Conjunction. This is also a very important thing. Hmm? So three things. One is disjunction, conjunction, and negation. Okay. So now we are at the second part, conjunction. So what is conjunction? Conjunction simply means and. And. Okay. Both true. Both true for P and Q. Is that clear? For disjunction it was or. For conjunction it is and. Okay. Now we just need to look like whether two statements P and Q. The compound statement means we are just linking it together with and. Okay, and we are linking it with and that is called the conjunction of the statements. Okay, and it is normally written as P like this. Okay, like this was first coined by a Russian mathematician, John Finkel, in 1924. That is just in irrespective, it is in irrelevant detail, but still I said we must respect all those who had found these kind of things, right? Now we will just go with some examples, right? Hmm. Let's see what example you can say that India is in Asian continent. Hmm? India is an Asian continent, we can say, and what you say, February 14th is Valentine's Day. So if we put this as P and if we put this as Q, then both stands true, right? Both stands true. So here P and Q is valid. So here both must be true. So I will just put it in bold. Both must be true. Clear? So both statements must be true. So let's just see another example. If we could just see, like, what should I write for this true? Okay, anything like what you can say. Hmm? Okay, P is equal to. Okay, I'm just going sine A plus B is equal to sine of A cos of B plus cos of A sine of B. So you might have studied, you should have studied, because while coming to real analysis, all these things are expected, that is there. Okay, and Q is a statement of sine square A is equal to cos square A is 1 minus cos square theta, is 1 minus cos square A, right? So these two statements I am given. So what is it here? This is it true? Yes, this is true. Is sine square A is equal to 1 minus cos square A? Yes, this is also true. Therefore what? P, this is the sign for and, conjunction sign. Okay, I'll again write it, conjunction sign Q. So this stands valid. So now is it clear that both the statements should be true? Then only it would be a valid conjunction. So in disjoint, I'm just repeating it, in disjoint, it's or, that is either. In conjunction, it's and, that means both. Clear? Now we are going to study the third one. Third one is most important, because you would be coming across all these things in your future course, and this is very important. These all things are primary. This is not just, we had not even entered the real analysis course.